In this video, we're going to talk about exceptions. So this is chapter 14 in the textbook that we're using. So the word exception simply means it's an occurrence of an undesirable situation that can be detected, okay, during your program execution. So if it's something that you can't detect, then you can't really do much about it. But if it's an error that can be detected, then you can handle it, right? So the biggest example, or the one you hear most commonly, is a division by zero error. When that occurs, it stops the program. It forces an immediate termination and gives you some random message that C++ has decided is what you need to hear. Okay. So some other examples of things that cause an exception, it could be if you're trying to open an input file that doesn't exist, or if you're trying to access an array position that's out of bounds. If you have an array of 10 and you try to go to the 11th element. Okay. So let's take a look first here at an example of a program that has the potential for an exception. Okay, so I've got a simple program here. It's going to go through and ask the user for two numbers, two integers, hopefully, X and Y, and then just print out the result of a division of those two. Okay. So of course, if this Y is zero, it's going to have an issue because you can't divide by zero. So let's take a look if I compile this program. Okay, I run it. And if I do like 5, 2, it's going to give me the answer of 2. Note that we're doing an integer division, so we only get an integer value. So one thing, for example, if I would do like a 1, 2, it returns a 0, which is okay. That's the integer portion of that division. Okay. But if I were to do something like a 1, 0, it's going to give me this error. Okay. It gives me a floating point exception here, which it doesn't really say division by 0. And I get a core dump here. Okay. So a core dump is a problem in that it's going to take all of the contents of memory and it's going to save it in a file. It's great for debugging for the programmer, but the user doesn't want that. Okay. And it's also never a good idea to have the program terminate and leave the user in some undetermined state. You want it to end when you want it to end. Okay. So this is not a great way to deal with this. So the things we've done to fix this in the past are a couple of things. We can look at the code to see. Okay, I think I've got this up here already. Yeah, here's the easiest way probably. We're just gonna put an if statement in here. Okay, so we're going to say if um, the denominator does not equal to 0, then we go ahead and do our division. If not, we're just going to print out some error message. Okay, so no big issue there. Okay. The other thing we can do that we sometimes do, we could do an example here. We could use the assert statement. I think we've used assert before. The assert is a function that takes a logical expression and then returns whether if it's true. No, it doesn't return anything. Sorry. If it's true, it ignores it. If it's false, it terminates the program. Okay. So in this case, the program looks exactly the same, but instead of our if block, we're saying assert. So we're making the assumption that y does not equal to 0. If that is true, it goes on program as before. If it's not true, then it's going to stop the execution of the program. Okay. Take a look at this one. See how it responds under error conditions. Okay. So if I do a 1 and a 0 here, okay. So it's this gives us a little more information, but again, this is programmer information. Okay. So this tells me that in particular, where in the program it happened, the user doesn't need to know that the assertion y does not equal to 0 failed. which means y must have equal to 0. It's aborted and there's a core dump. So again, we have the whole problem with a core dump, which is not great. Okay. So now that we've done those tests, okay, we still have some issues, okay, and that's just the issue that we don't have control. Okay, we don't have control over what's going on, and that can be a problem for sure. Okay, so what we're going to do to fix this, okay, we're going to use this try catch block, and most languages have this. It seems like in Python there's a try catch, but it's a little bit different here. Okay, so you put the try block around code that could generate an exception, and then you have catches to deal with it. Okay. So let's start by looking at the basic syntax of what that looks like. Again, all this stuff's in the book. I have some different examples in some cases, but in general, this is what the book talks about. Okay. So this is a code snippet, of course. We have our try block, and then we have code inside of here, just your normal programming, no change at all. That could generate an exception. If you're doing a division, that could be 0. If you're accessing a file, if you're accessing an array, any of those things. Okay. If your code is not inside the try block, none of this is going to happen. Okay. And then we have the catches here. Okay. So the catches here are some data type with an identifier. And then we're going to have our exception handling code. You can have multiple catches if you want. Okay. And then this last catch here with the 3 ellipses there at the bottom, it'll catch whatever gets left. Okay. So once the try block, or sorry, once the catch block happens, then whatever left in the try is ignored. Okay. It stops that entirely. Okay. And the way these work, if you have multiple exceptions or poorly worded ones, it's going to catch the very first one and that's it. Okay. Kind of like a case statement works in that sense. Okay. So that's how the general part of that works. Okay. So inside of this try block, the way we have it set now, we have to throw an exception if we're going to have it be caught. Okay. So we can look at some examples of that. Okay. So again, just having the structure of a try block doesn't do you any good until you actually try to throw something. Okay. So let me take a look. I think I've got an example. Maybe I don't have an example of this. That's very interesting. Yeah, it looks like I don't. Okay. Which is okay. It's just the basic idea that when we're to throw our exception, we have to go inside of the try block and we have to throw an error that we can then catch in one of our catch blocks. I actually paused and put up the example from the book just so we can see this. So here we have in our code, kind of what we had before, different variable names, the same idea. In our try block, we're doing the same thing. We're entering in the dividend, the divisor, numerator, denominator, x, y, I called it, okay? And then we're doing our test here. If divisor is equal to 0, we're going to throw 0, okay? We're throwing that exception 0, okay? And in this case, we're going to catch this integer. We don't care what it is. We're only throwing a 0. So whatever gets thrown here, we could throw a 5, we could throw a 21, whatever, as long as it's an integer. Because we only have one error, okay, then it's going to print out this division by 0 error, okay? So that's kind of how that works if you're using the try catch block in this way, okay? So the other thing that you can do here is C++, C11, this book calls it because we're in version, we're I think 11.4 on the system. Version 11 of C++, okay, has some classes that come built in. So there's a class exception, and it's the base class. And in particular, this is an abstract class that has a what function as a pure virtual function. Okay, WHAT what. So this what function is going to return a message. It's going to print out a message that contains an appropriate message for that error. Okay. So all classes that get derived from what or sorry, derived from the class exception have to override this function what? It's an obligation. Okay. So we immediately, so they, not we, it has been derived for us this logic error and runtime error, which are derived from class exception, and they're in the standard accept library. Okay. So let's take a look at what that looks like. So here we have to include the standard accept if we want to be able to get this standard, this logic error. Okay. And here I've just created a calculator class, pretty basic. Okay. So we've got this function to divide two numbers with the exception handling. Okay. I always like to do it this way. So we've got this divide function, takes a numerator, denominator. Then we've got if the denominator is equal to 0, then we're going to throw a logic error with the message division by 0 is not allowed. Okay. We're then going to return, okay, if it made it this far, we're going to return the numerator and the denominator. Okay. So in our int main, we just create our calculator, we create our numbers and enter them. Okay. We then go into our try block when we're going to actually do the division. And the other examples, we were asking for the input inside of the try block, but we didn't really need to do that unless you're worried about capturing if they don't enter an integer. So that, I guess that's why it could be there. So we're then going to call the divide function. We're going to print out the result. But we've got our catch block here with this logic error E. Okay. We can then call the what function on E. Okay. And that should print out the error message that we sent it. So when we create it, we're setting what the what does for us. So the logic error has the what function to take a string that it then returns. Okay, so that's basically the idea there. Okay, so if we were to run this, I'm just going to do this the quick and dirty way and do it as an a dot out. Okay, if I do, a 1, 0, that it's going to pop up this logical error. Okay, and say that the division by 0 is not allowed. Okay, so that's another way that you can do that. So you can, in addition to this, you can create your own exception classes if you want. Okay. So whenever you create a program or a class, it's pretty likely there are going to be exceptions that can occur. Okay. So we can use the techniques we've talked about so far, or sometimes you'll want to create your own exception classes. Okay. To handle things either in your own way or to handle things that would not be exceptions to the compiler, but are exceptions in your program. Okay. So we can start this process here. Look at this division by 0. We're going to do a header file here. So we're going to create this class called division by 0. Okay. Now note that I'm not inheriting from the exception class. Okay. So it's because of the way we use it that it's an exception. Okay. So that's a little bit different. Okay. So in this one, this is our class division by 0. It's got the public function division by 0, which just has the message division by 0. Okay. And then this division by 0 function can also take a string, in which case the message would become that string. Okay. Here's our what function that returns the message. So it either gets a custom message or it gets the division by 0 as a normal message. Okay. And then the private data is just the string message. Okay. So let's take a look at the program that uses this. Okay. So in this case, we're including here our division by 0.h file, the header file. Okay. Then we're going through again inside of our try block, we're entering the dividend, ending the divisor as before. Okay. And we've got here, if the divisor is equal to 0, just like to put brackets in there. Don't know why I didn't. Okay. Then we're going to throw the division by zero, okay, which is defined in the division by zero.h. Okay. If not, we're going to go on our happy way. Okay. So we throw it, we have to catch it down here, this division by zero object. Okay. And then we can say in the division by zero catch block, just to let us know that we're there. And then use the what function to print out that error message. Okay. So this is a way to create our own custom exception classes. And there are more examples of this in the book for sure. Okay. So the last thing we're going to talk about is just in general, the options you have when you hit an exception. Okay. And there really are three. So you can choose to terminate the program. It could be that the error generated is so bad that you just can't go on. So you can terminate the program. Okay. If you do that, you want to make sure you let the user know what's happening. You want to make sure the program gets back to some stable state. If you have to save things, if you have to do whatever you have to do, but let the user know in a clear way, clear to them, not clear to a programmer, what's happening, and terminate the program. Okay. You can choose to fix the error and continue. If they've entered a zero as the divisor, then you can just ask them to enter it again. Certainly something that you can do. Or it could be if it's a file name issue, you ask them to enter it again, whatever you need to do to fix it. Okay. Then the third option that makes a lot of sense a lot of times is you want to create a log file of the error and then continue anyway. Okay. So this idea of exceptions is important to our programs. We want our programs to be robust. We want them to perform the way the users expect. And part of that means not having buggy programs, not allowing the code to produce erroneous results, or just to have a segmentation fault or a core dump or any of those things. So it's important that we take care of our users. When I was a young programmer, I used to think it was an issue for the user. If they put in bad data, that's their fault. But it's not. As a programmer, it's our responsibility to protect the user from themselves and to make sure our programs always exit gracefully. Okay. In the previous class and probably in this one, at times we're going to ignore the idea of error corrections and of exceptions just for expediency. We're trying to get a lot covered. But keep in mind that programs that you do for real, not in a class, should definitely be as bulletproof as you can make them. Okay. So, as always, if you have questions, make sure you let me know.